So far, our discussion on particle motion was concerned about motion of particles in one dimension. In other words, we considered a particle moving either in the x direction or in the y direction. Now, do you remember the equations of motion for a particle that is moving in the x direction? Let's write the equations of motion for a particle that is moving in the x direction. Now, the first equation will be Vx equal to Vx0 plus At. What does that equation mean? V sub x is the x velocity at any given time, is Vx0 stands for the initial x velocity plus a times t. The displacement x equal to x0 plus Vx0t plus 1/2 a t squared. That is the displacement equation. And Vx squared, the final x velocity squared, is Vx0 squared plus 2ax. Well, these are the equations adapted for x motion. Now, what will happen to these equations when you want to discuss y motion? Well, when you want to discuss y motion, it will become Vy. The y velocity at any given time is Vy0 plus, well, you see, when you consider y motion, the acceleration a will become negative g. So, in place of plus at, it will become minus gt. I hope you understand that. For a vertical motion, the acceleration is negative g. So the a gets replaced by negative g. And the displacement equation y equal to y0 plus Vy0t. What does Vy0 stands for? Initial y velocity minus 1/2 gt squared plus 1/2 at squared become minus 1/2 gt squared. And finally, Vy squared equal to Vy0 squared minus 2gy. So these are the equations. This is specifically for x motion and this is specifically for y motion. Well, in this lesson we are going to look at motion in two dimensions. That means an object will be moving in the x direction as well as in the y direction simultaneously. Now, look at the gun I have here. I can actually project a ball from this gun. I can load the gun. And I'm going to project it horizontally. When the ball comes out, the moment it comes out, it will have an x motion and a y motion. See if you can, try if you can see the motion of the ball. There you are. Now, did you see how the ball was moving? Well, I want to take you to an animation and show you how the ball was moving. Give me a second. To illustrate motion in two dimensions, I have arranged 3 balls here. The ball sitting on this platform can only move in the x direction. This ball can only move in the y direction. whereas this ball is going to be projected horizontally. Alright, I want you to watch the motion when I run this animation. Alright, watch carefully. I'm going to run it. And watch each frame. There you are. Now, what do you observe? If you look at this, well, this thing did not move. Alright, I'm going to run it again, and I want you to watch it carefully. What I have done is, the horizontal velocity I have given this ball is the same as the horizontal velocity for the ball that can only move in the x direction. So this will move in the x direction with a velocity of 8 meters per second. This is given a horizontal velocity of 8 meters per second, but it is not supported. It is like the ball that was fired from the gun. Alright, watch this animation one more time and watch it carefully. Now, what you notice is this. After 1 second, the ball that is projected, the initial position of the ball was here, if you notice. And unfortunately, those initial positions are not shown in this animation. The ball that is fired or projected is now here. It has now a vertical motion and a horizontal motion. And look at the ball that is moving horizontally only. It has moved the same horizontal distance. And look at the ball that is being dropped. It has dropped the same vertical distance. You see that? After 1 second, the horizontal position of the projected ball and the horizontal motion of the ball that is moving on the platform are exactly the same. Similarly, the vertical motion of the projected ball is exactly the same as the vertical motion of the freely dropped ball. Look at the velocity, the vertical velocity of the dropped ball is exactly the same as the vertical velocity of the projected ball. Now, look at the position after 2 seconds. The vertical position and the horizontal positions are exactly the same. That means the horizontal and vertical motions of this projected ball are independent of each other. What does that mean? It means this horizontal motion will not affect the vertical motion, and the vertical motion will not affect the horizontal motion. We can treat each motion as though the other did not exist. That means we can use the equations of motion to describe the x motion of this ball and y motion of the same ball. Now tell me, the velocity of this ball, x velocity is vx. You look at this. What happened to vx with time? As the ball keeps falling, what is happening to the x velocity? The x velocity is not changing. Why is it not changing? Because there is nothing pulling or pushing in the x direction. In order for the velocity to change, there must be some force. Since there is no force in the x direction, the x velocity will remain the same. And that's the reason why the motion of the ball on the platform that has the same x velocity is exactly the same as the motion of the projected ball. Okay, let's go and look at the motion in 2 dimensions constitute a projectile motion. So a projectile launched into space constitute motion in 2 dimensions. A projectile moves in the x direction and y direction simultaneously. A projectile may be launched horizontally, just like I just showed you, or at an angle theta with the horizontal. Now this is an example of a horizontal projectile. What you notice here, you are projecting a ball from a certain height with a velocity, with a horizontal velocity v sub x. Now what is the initial vertical velocity of the projectile? The initial vertical velocity of the projectile is 0. Vertically, it is not moving in the beginning. It has an initial horizontal velocity and it has an initial vertical velocity that is 0. And you can see, as the projectile keeps moving, the vertical velocity keeps on increasing. What is the equation for that vertical velocity? Vy equal to Vy0 minus gt. You can see the velocity keep on increasing in the negative y direction. What happens to the horizontal velocity? The v sub x will not change because there is nothing pulling or pushing in the horizontal direction. Well, projectiles at an angle we will discuss in our next part of this lesson. Okay, now a horizontal projectile, that is what we're going to concentrate on this part of the lesson, has a horizontal motion and a vertical motion. And I showed you some time ago that the horizontal and vertical motions are independent of each other. What does that mean again? The horizontal motion does not know that there is a vertical motion. In other words, the horizontal motion will not affect the vertical motion, and the vertical motion will not affect the horizontal motion. Now, take the same example. The horizontal motion continues as though there is no vertical motion. In other words, the horizontal motion of this projectile here is exactly the same as the horizontal motion of the ball on the platform. You see? The horizontal motion continues as though there is no vertical motion. And the vertical motion continues as though there is no horizontal motion. The y velocity will keep on increasing according to the equation Vy equal to Vy0 minus gt. The horizontal velocity v sub x remains a constant. And